Hello, my name is Kirk Stewart. I am the CSO / General Manager of Sales for SW North America. You join me here at IMTS here on the last day, the 6th day of IMTS. Has been a great show. So one of the things we tried to do coming into the show was really focus on where we're excelling in the market. And if you read the news, especially automotive news, there's great changes to electrification in the automotive industry. So behind me I have the machine, the W08-12 machine. So unique things about this machine are the fact that I'm running linear motors. We'll take a look at the tool path in a little bit, but so fast and efficient. 120 meters per minute, 50% greater acceleration versus ball screws. And I think one of the biggest unsung benefits of linear motors versus that of ball screw is a reduced and eliminated maintenance cost. Linear motors simply don't fail compared to ball screws. So this is the component which we're showing, which is a big block of aluminum, which is kind of replicating a battery tray for an electrified product. It's not any specific design, just a dummy part for cutting a lot of chips here during the course of the 6 days. So you see a lot of machining. We machine it from billet, and we've removed about 5 barrels of chips per day. Really exciting stuff. So on the front side of the machine, we just have the part shown here, but typically this would be laying horizontally for the load unload. So it's very similar to a vertical machining center. I can very comfortably bring in my part and doing the load unload. So this is one of the unique aspects of the SW machines, in that we have a load unload area and then we also have a machining area. Unlike a pallet changer system, we are not machining onto a tombstone and having traditional forces trying to deflect. Really, this whole trunnion, which is carrying the table, is allowing us to machine directly into the structure of the machine. So it's a much more rigid and robust setup on the machine. So one of the things that I always like to show is the side view of the machine. You can see this really large machining envelope. Right now we're cutting the part and starting to hog it out, getting rid of these chips. And I'm not sure if we're going to see a tool change. We're just hogging out the ribs, going down to that next profile. But moving around, you really get to see that velocity of the linear motor machines. So this machine is also a single spindle machine. Typically with SW, we're going with 2 or 4 spindles. That's really our core product. But we found that a lot of these components in the electrified space are long rectangular components. They fit really nicely in that envelope of the machining area. So the W08-12 single spindle, 2 tables for very fast workpiece exchange, all on linear motors, which makes that productivity of the machine so much more important. So very, very fast workpiece change, which is very good for the operator. You can tend many machines, which is very important. Reduce the number of men required in a cell. It's a lot less burdensome on that front. Very difficult to get operators nowadays. So very fast machine, great for aluminum or any other non-ferrous product, the W08-12. So the second area which we wanted to focus on here at IMTS is the firearms industry. Very similar to automotive, there are high volume of parts running through our customer shops, and that's where SW comes to the table, just very highly productive solutions. So the machine behind me is the BA322i, and I want to focus on the I part of this solution first. This is our integrated bolt-on automation solution. Basically, it's a machine tending unit that's coming standard from SW and our 2 and 3 series machines. So on this side of the machine, we are loading in all of the trays. We can put a dozen trays in there. Each of those trays are about yay big. We can load up 6, 12, 24 components depending on the size. Really gives our customers the opportunity to run lights out, just really tending the machines to make sure you have enough material running in. So that's the left-hand side where the material is coming in. Now we want to switch over to the robot load-unload area. Okay, now from this side you can get a little bit idea how this work envelope is working. We have the robot hanging from above. The robot's responsible for dragging the tray of components in and then taking the components into the work area. So we're not quite ready for a work exchange, but we have the secondary door. First door is for the safety from the robot. Second door is to constrain the chips and coolant in the exchange area. So this door will open at the end of the cycle, and that will give access for the robot to take the raw parts in, but first bring the finished parts out. When we bring the table into the exchange area, We first flip it upside down so we're able to flush off all the chips with coolant and air, bring it back horizontal, open the door, take the parts out, and then actually close the door a lot of times, rotate it back up upside down again and flush it once more. So when you're an automated system, to get rid of those chips for a clean workpiece and fixture for exchange, very, very important. And then clearly when we have two operation processes, we have a nice little staging area for workpieces as well. So what you see in here as well is now we switch over to twin spindle machining. And this is really SW's core business, is milling machines with two spindles. You know, if you need to make a lot of parts, why not make two at the same time? Why not make four at the same time? From the floor space as a very paramount need in today's environment, you're basically getting double the output in the same floor space of a traditional horizontal machine. So floor space is huge. You also double or quadruple that output with 2 or 4 spindles, which means on large production programs, you're reducing your number of operators which come to the machine. You're reducing the energy consumption. You have one chip conveyor, you have one HMI, one mist collector. All these things are amortized over 2 spindles. So energy savings, floor space, reduction of manpower are so core to running with 2 or 4 spindles. So let's take a look in the operating zone really quickly. So this is from the operator's view of the machine, and as you can see, we're cutting 2 parts at once. Unfortunately, here at the 11th hour of IMTS, we've run out of materials. Our machines are so fast, we ran out of material, so we're only cutting air today. But really, you can see that benefit of cutting 2 parts at once, double the productivity, all in one footprint. The other thing I'd like to highlight is the fact that, you know, in any horizontal machining center, you're going to be better off in regards to your chip flow. Our machines start off as a basic solution at 4-axis. We don't have any 3-axis solution, so we're always having that ability to machine the parts upside down and allow for that really good chip evacuation. Our 4th-axis units can also be fit with planets, 5th-axis planets, and that's what you're going to see in this configuration for this firearms component. So really, worst case scenario, we're machining from the front, but typically upside down, whichever orientation is required for the component. So twice the spindles, double the output, a fraction of the floor space and a fraction of the energy. This is really what brings SW to the forefront of those productive manufacturing solutions. So hopefully that was an informative introduction to the SW machines. If you have any questions after IMTS, by all means reach out to us. You can find us at sw-machines.com.